Everybody look, example 12. All right, so for example 12, we're to find and simplify. All right, so this would be equal to, from r is equal to 1 to n. I would do from r is equal to 1, from r is equal to 1 to n first. You don't have to, but I would do that. And this is, so 3 times r plus, from r is equal to 1 to n of 2. This becomes 3 of times what? N into n plus 1 over 2 plus 2n. Put this over 1. The LCM is 2. 2 into 2 is 1. 1 times 3n into n plus 2 is 3n into n plus 1, sorry. So this is 4n. Simplify, factor out the n. We get n over 2. And we have 3n plus, all right, let's just, so we have 3 into n plus 1 plus 4. And then now this becomes, n over 2, distributive law. We have 3n plus 3 plus 4. This is n over 2, 3n plus 7. Now, so that is sigma from r is equal to 1 to n of 3r plus 2 is actually equal to n over 2 into 3n plus 7. Now, if we want from when r is equal to 1 to 2n, wherever I see n of 3r plus 2, wherever I see n, I would put 2n. So we have 2n over 2 into 3 times 2n plus 7. And my final answer is n into 6n plus 7. So from r is the summation of 3r plus 2 from r is equal to 1 to r is equal to 2n is n into 6n plus 7. All right, example 13. Example 13 says, show that the sum of the series r into r minus 1 from r is equal to n plus 1 to 2n is equal to n over 3 into 7n squared minus 1. Now, I would say that this series should actually be equal to the summation from when r, all right, let's not go there first. Let us find this first. From r is equal to 1 to n of r into r minus 1. I would find that first. And this is equal to the summation from r is equal to 1 to n of r squared minus the summation from when r is equal to 1 to n of r. Now, this would be n into n plus 1 times 2n plus 1 all over 6 minus n into n plus 1 all over 2. So the next thing I would do then is, let's change the color in here. I would then multiply the numerator and the denominator by 3. That is so that I get a common denominator. Then I would factor out n into n plus 1. I would then factor out n into n plus 1 over 6. Then in bracket, I would have 2n plus 1 minus over here, so to the right, I would have 3. Now, this would work out to be n into n plus 1 over 6. And in bracket here, we have 2n minus 2. If I factor out the 2, I would have 2 into n plus 1 multiplied by n minus 1. Sorry, I left out something. It's 2n into n plus 1 multiplied by n minus 1 because I factored out the 2 and this is over 3. This would work out to be, sorry, not 3, jumping the gun, over 6. This is 1, this is 3. So now I have 1/3 n into n squared minus 1. So whenever you multiply the sum and the difference of the same two terms, the answer is the difference of the square of what? Both terms. Everybody know that. All right, so this is what from 1 to n of r into r minus 1 is equal to 1/3 n into n squared minus 1. But what we want to find is this. From r is equal to n plus 1 to 2n of r into what? R minus 1. And this would be equal to from 1 to 2n of r into r minus 1 minus from 1 to n of r into r minus 1. Do you agree? Now, so using the formula to the left, wherever I see n, I'm going to put 2n. So it's 2/3 n, and then what? 2n squared minus 1. And then over here, so it's that's the same as what we have up there. So it's 1/3 n into n squared minus 1. All right, the denominator is common, so I can form one fraction. So this becomes, or we could just factor out 1/3 n. So it's n over 3. And in bracket, I have 2 into 2n squared, which is what? 4n squared minus minus 1. And then over here, minus n squared minus 1. So what we have here is n over 3. Then we have what? 8n squared minus 2 minus n squared plus 1. So our final answer is going to be n over 3 into 8n squared minus n squared is 7n squared minus 2 plus 1 is minus 1. And so the summation from r is equal to 1 to 2n of r into r minus 1. Sorry, this is from n plus 1. R into r plus 1 is equal to, what did they say it should be equal to? And that's exactly what we have. It's equal to n over 3, open bracket, 7n squared minus 1. Okay. All right, so example 14, very similar to example 13. So remember what I told you I would try to find first? I would try to find from R is equal to 1 to N of 3R plus 4. I would try to find that first, and this would be equal to 3R from R is equal to 1 here to N plus 4 from R is equal to 1 to N. This would work out to be 3 into N, 3N into N plus 1, all over 2 plus 4N over 1. Now, this would be equal to LCM is 2, 3N into N plus 1 plus 8N. Let's factor out N. So we have N over 2. Inside the bracket, we have what? 3 into N plus 1 plus 8. Then we have N over 2. Then we have 3N plus 3 plus 8. So now we have N over 2, 3N plus 11. And that is what this is equal to. From 1 to N of 3R plus 4 is equal to N over 2 into 3N plus 11. But what we're asked to find is this. From R is equal to N plus 1 to 2N of 3R plus 4, and this would be equal to from R is equal to 1 to 2N of 3R plus 4 minus from when R is equal to 1 to N of 3R plus 4. Using our formulae, or the formula that we just derived, using that formula, we can now say that 2N from, sorry, we can now say that the summation from R is equal to 1 to 2N, sorry, from R is equal to N plus 1 to 2N of 3R plus 4 would be equal to, wherever I see N, I'm going to put 2N, so it's 2N over 2 into 3 times 2N, 3 times 2N plus 11 minus N over 2 into 3N plus 11. So let's simplify. Let's factor out N over 2. So we have N over 2. Inside the bracket, I would have 2 into 6N plus 11 minus 3N plus 11. Be careful not to make any mistakes. N over 2. Then we have 12N plus 22 minus 3N minus 11. So now we have n over 2 into 9n plus 11. All right, so this I think is what we're after, that the summation from r is equal to n plus 1 to 2n of 3r plus 4 is equal to n over 2 into 9n plus 11.